Gravity was the first force to be understood scientifically, though 3 more would eventually follow. And although Newton discovered his law of gravity more than 300 years ago, his equations describing this force make such accurate predictions that we still make use of them today.
In fact, scientists needed nothing more than Newton's equations to plot the course of a rocket that landed men on the moon.
11, this is Houston.
Yet, there was a problem. While his laws described the strength of gravity with great accuracy, Newton was harboring an embarrassing secret. He had no idea how gravity actually works. For nearly 250 years, scientists were content to look the other way when confronted with this mystery. But in the early 1900s, an unknown clerk working in the Swiss Patent Office would change all that. While reviewing patent applications, Albert Einstein was also pondering the behavior of light. And little did Einstein know that his musings on light would lead him to solve Newton's mystery of what gravity is. At the age of 26, Einstein made a startling discovery: that the velocity of light is a kind of cosmic speed limit, a speed that nothing in the universe can exceed. But no sooner had the young Einstein published this idea than he found himself squaring off with the father of gravity. The trouble was, the idea that nothing can go faster than the speed of light flew in the face of Newton's picture of gravity. To understand this conflict, we have to run a few experiments. And to begin with, let's create a cosmic catastrophe. Imagine that all of a sudden, and without any warning, the sun vaporizes and completely disappears. Now, let's replay that catastrophe and see what effect it would have on the planets according to Newton. Newton's theory predicts that with the destruction of the sun, the planets would immediately fly out of their orbits, careening off into space.
In other words, Newton thought that gravity was a force that acts instantaneously across any distance, and so we would immediately feel the effect of the sun's destruction. But Einstein saw a big problem with Newton's theory.
A problem that arose from his work with light. Einstein knew light doesn't travel instantaneously. In fact, it takes 8 minutes for the sun's rays to travel the 93 million miles to the Earth. And since he had shown that nothing, not even gravity, can travel faster than light, how could the Earth be released from orbit before the darkness resulting from the sun's disappearance reached our eyes? To the young upstart from the Swiss Patent Office, anything outrunning light was impossible. And that meant the 250-year-old Newtonian picture of gravity was wrong.
If Newton is wrong, then why do the planets stay up? Because remember, the triumph of Newton's equations come from the quest to understand the planets and the stars. In particular, the problem of why do the planets have the orbits that they do. And with Newton's equations, you can calculate the way that the planets will move. Einstein's got to resolve this dilemma.
In his late 20s, Einstein had to come up with a new picture of the universe in which gravity does not exceed the cosmic speed limit. Still working his day job in the patent office, Einstein embarked on a solitary quest to solve this mystery. After nearly 10 years of racking his brain, he found the answer in a new kind of unification.
Einstein came to think of the three dimensions of space and the single dimension of time as bound together in a single fabric of space-time. It was his hope that by understanding the geometry of this four-dimensional fabric of space-time, that he could simply talk about things moving along surfaces in this space-time fabric.
Like the surface of a trampoline, this unified fabric is warped and stretched by heavy objects like planets and stars. And it's this warping or curving of space-time that creates what we feel as gravity.
A planet like the Earth is kept in orbit not because the sun reaches out and instantaneously grabs hold of it, as in Newton's theory, but simply because it follows curves in the spatial fabric caused by the sun's presence. So, with this new understanding of gravity, let's rerun the cosmic catastrophe. Let's see what happens now if the sun disappears.
The gravitational disturbance that results will form a wave that travels across the spatial fabric in much the same way that a pebble dropped into a pond makes ripples that travel across the surface of the water. So we wouldn't feel a change in our orbit around the sun until this wave reached the Earth. What's more, Einstein calculated that these ripples of gravity travel at exactly the speed of light.
And so, with this new approach, Einstein resolved the conflict with Newton over how fast gravity travels. And more than that, Einstein gave the world a new picture for what the force of gravity actually is. It's warps and curves in the fabric of space and time.
Einstein called this new picture of gravity general relativity. And within a few short years, Albert Einstein became a household name.